Welcome to the webinar for Urbano software. Today we will present the new Urbano Canalis 11 for sewage design. I will be your host today. My name is Michal Vajc, and let's go right through the agenda. So after this short introduction, we will go to the live presentation. And after the live presentation, we will, of course, host questions and answers. For those of you who don't know Urbano software, we are now more than 30 years developing Urbano software for pipe network design, calculation, analysis. So you can do a lot with Urbano software, design plans and profiles, calculate and optimize pipe networks, analyze with maps, labels, tables, queries, and various other tools. Also, there's a lot of possibilities to connect GIS data, so CAD, of course, hydraulic modeling software, BIM software for various BIM workflows, and so on. And last but not least, you can customize functions, catalogs, even the user interface, and of course we can help with all of this. The live presentation will last about 60 minutes. We will follow up with a questions and answers session. Everybody will be muted during the presentation, but you can write your questions in the questions panel. And in the case you have technical issues, please write to the chat. But you know, sometimes it just helps to log out and log in again, or maybe restart your browser. In any case, we will send the recording to all who registered for the webinar. So everybody who registered left their email, and you will all get the link to the recording probably tomorrow. And of course, we will also post the link to our various social channels. So after the webinar, there will also be a short survey, so just 4 questions, and those 4 questions you will be able to request an additional Teams meeting, or maybe essentially ask any question about the program. Okay, so with this out of the way, I would like to introduce my colleague Rino, who will now take over with the live presentation.
Thank you, Michael, for your introduction. Hi and hello to everyone. My name is Rino and welcome to another Studio Ars Urbano webinar. Today's topic will be Urbano Canalis, our software for storm and sanitary network design, analysis and hydraulic calculation. In the following 50 minutes of live presentation, I will show you full workflow from the creation of the network in plan and profiles to hydraulic calculation and exporting of 3D BIM model to IFC. During the presentation, I will also show you some very exciting new features of Urbano 11. So let's start with the live presentation. As you can see here in this drawing, I have just this raster image of this area and these road edges that I received from a road designer. Here you can also see the existing standard T intersection that will be replaced with this new roundabout on a slightly different location. What else I have in this drawing? I will show you. I have 2 DTM surfaces. So this is existing ground surface. So if we take a look at it in 3D, we can see this is Civil 3D DTM surface. And it is important to say that if you run Urbano on top of Civil 3D, you can use Civil 3D DTM surfaces directly. But if you run Urbano on plain AutoCAD, you can also use our own DTM modeler, which is called Terraform. Okay, so this is the existing ground. And also I will show you the finished ground, which is this road surface that I received from the road designer. And this will be our reference surface to design our storm network. Okay, let's go back to plan view. And again, let's switch to a different layer state where I have some helping layers, some helping points, that I will connect by drawing the network interactively. And also I have some AutoCAD polylines that I will use to convert to Urbano Storm network. Okay, so first way how you can draw the network in Urbano is by drawing interactively in plan. And here in this dialog, you can see that you can set up many different options and parameters. For example, you can automatically set terrain elevations from selected DTM surface. You can automatically set invert elevations to be on a constant depth below terrain. And also you can set pipe group and pipe diameter from the pipe catalog. So let's click draw. And now I will turn on AutoCAD OSNAP to just snap to the centers of these circles. And notice how I am clicking. The elevations are being automatically read from the selected DTM surface. Okay, so we draw one part of the network interactively. And let's now convert these AutoCAD polylines. So let's open the second function, conversion of CAD elements, where you can set up all the same options as in the previous dialog. And also you can use this really nice function for layer filtering. So just select some element in plan. The software recognizes which layer this is. And now we can freely select the entire drawing. And the software will select just those elements on selected layer. So now when we click convert, everything will be converted from plain AutoCAD polylines to Urbano Storm network. Okay, so now that we draw our network, let's also label it. I will use default labels for nodes and also for sections. And notice, because these fonts are quite big, we had a lot of these overlappings of the labels. But this can also be resolved really easily by interactively moving some labels one by one, or we can start this really nice function for automatic label reposition, where you can define some parameters for moving. And when we click apply, all these labels that are overlapping will be moved, so there is no more overlapping between these labels in the entire drawing. Okay, let's now turn off these helping layers and let's focus just on the Urbano network. And the best way to analyze Urbano network is always by using Urbano data tables. So here in the workspace, you can see that each function in Urbano can have multiple configurations. And these configurations are basically sets of predefined data, settings, options, and so on for each function. So, for example, let's open these data tables. And here you can see that you can switch between these data configurations. Of course, you can edit them, you can create your own. And if I select some configuration, you can see that you can preview all the data for all the elements for the entire network, or you can use these selection options to select just some parts of the network. For example, if we go to selection of sections, I can select, for example, these 3 sections, and I will get their data in the data table. But also in Urbano, we have more intelligent selection options. For example, selection of branches. And now you will see what is a branch in Urbano. So a branch is basically everything in between 2 main nodes. So between starting, ending, and branching nodes. So if I select this branch, I will get all the sections that belong to that branch. Also, we have something that we call arrays. And these arrays are basically arbitrary topology groups that the user can create by himself. You can edit them, you can split them, merge them, and by default, one array is one part of the network that you draw at once interactively, or one original polyline if we converted it from CAD elements. So now if I select this array, I will get all the sections that belong to that array. But also, we can switch to a different data table configuration for arrays. And now if I select the entire network, I can see the total group data for the entire arrays. So we see A1, A2, and this little one is A3. Okay, let's rename these arrays now. In Urbano, there are multiple ways how you can rename all the network elements. So the easiest way is always by using the data table. So all the white cells in the data table can be edited directly by double-clicking in the cell. But I would like to show you one new function from Urbano 11 for automatic renaming of the arrays. So let's go to Edit, Rename Arrays According to Rules, and here you can choose between 3 different rules, and I will select the first one according to arrays hierarchy. So you have to select what will be the main array, then you have to select arrays to be renamed, give a main array name, and set some delimiter. And now when we click Rename, all the arrays will be renamed according to that rule. So now if we sort the data table, we see we have the main array A1, we have A1.1, and this little one will be A1.2. Okay, so now that we renamed the arrays, let's also check the data for the nodes. So let's switch to a node geometry data table where we can see all the data about the nodes. Again, there are multiple ways how you can rename your nodes, but I like to use this automatic option, rename by distance, where you can select the entire network and then you can give a prefix or suffix. In this case, I will set a suffix A, and when we click Apply, all the nodes in the entire network will be renamed according to that rule. So the software is searching for the node that is furthest away from the outfall, and it gives that node a smallest node name. Then it goes up to the branching of the network, and then again searches for the node that is furthest away. And then if we go to the last node of the system, we see that that node has the biggest name. Okay, so let's now also rename the sections. Let's switch to section geometry, and like I said, there are multiple ways how you can rename them using multiple different rules. And for the sections, I like to use this option to rename them automatically using these patterns from starting node name to ending node name. So now when I click Apply, all my sections will be renamed in a way that the name of the section is from starting to ending node name. Okay, so now that we know everything there is to know about Urbano topology and selection options, let's also draw profiles. To draw profiles in Urbano, it's extremely easy. Basically, all you have to do is just select a profile configuration and everything is stored inside, from the scale to the data to language, basically everything. So I will select the entire network and we will draw these profiles according to arrays. And let's place them all in one row. And when we click Draw, we just have to define the insertion point and the profiles will be drawn. Another great way how you can draw your profiles is by using this selection option from node to node, where you can go basically from any node to any node in any direction. For example, let's end up here in the last node of the system, and let's place this profile here. Let's do another one. Let's go from this node all up to the last node, and let's place this profile here. Okay, so now that we drew the profiles, let's also check them. So we can see that we have just one terrain line. This is the gray line of the finished ground surface that we defined automatically while drawing. But if we want to show more terrain lines in profiles, we can do that as well. So let's go to function for setting terrain elevations from digital terrain model. Let's select entire drawing, and from Civil 3D DTM surface, we will set the existing ground into terrain number 2. So here you can see that in Urbano you can set up to 10 different terrain levels. Okay, let's save. And now you will see that additional terrain line will appear in profiles. So this green line is showing us the existing terrain. Now if we select this polyline, this terrain polyline, you see that we have a lot of these vertices, or as we call them in Urbano, additional points. So these are basically places in plan where our sections are crossing the triangles of the DTM. And because this DTM is very dense, you see that we have a lot of these unnecessary additional points. Because of that, in version 11, we added a new function. Here under the system settings, you can turn on additional point reduction and also define reduction tolerance. For example, let's set this tolerance to 5 centimeters and let's click OK. notice how the profile will automatically update. And now you can see that we significantly reduced the number of those unnecessary points. But for example, if we take a look here, we see that maybe we went a little bit too far. So let's go back to this function and let's decrease this tolerance to 1 centimeter. So 1 centimeter is pretty small tolerance, and you can see that now this is more smooth, but still you see that we significantly reduced the number of these additional points. Okay, let's now also set the manholes. Let's go to function for setting of the manholes, and from the manhole catalog you can choose between many different manhole types, shapes, sizes, materials, and so on. I will select this PEHD manhole of 1000 millimeters diameter, and I will select the entire network and just click Save. Okay, we will see that the manholes and the manhole labels will automatically appear in the profiles, and in these labels we can see the manhole name, terrain elevations, and also invert elevations. Okay, if you remember, while drawing, I placed my pipes to be on a constant depth below terrain, and which ended up being pretty nice solution for these first two profiles. But if we take a look at the third profile, we see that we have a negative slope here. In Urbano, there are many different ways how you can define your pipe invert elevations automatically or interactively. First function that I would like to show you is this automatic invert calculation according to rules, where you can define minimum and maximum depth below terrain, minimum and maximum slope, and also some drop manhole parameters. So let's select the entire network, let's calculate, let's apply the changes, and let's save this configuration. And now you can see that we have a new solution of the pipe invert positions. So the software did some modifications. We can see that it inserted the drop manholes on some places, and also the pipes are a little bit deeper. Okay, if you are not 100% satisfied with this solution offered by the software, of course you can continue editing these pipe invert positions by interactively drawing or editing pipe invert directly in the profiles. I like to use this option, input and edit pipe invert, where you can basically straighten or even draw your pipe invert by line or by slope. And when I say pipe invert, it doesn't have to be actually just the invert. You can select what is the reference point on the pipe. It can be, for example, top of the pipe, bottom of the pipe, axis, or invert. We will go with the top of the pipe. So now, for example, let's select some part of the profile. Let's go from node 1 to node 5. And first I will use this option to straighten the pipe by line. And here you can define starting and ending depth or elevation. For example, let's increase the starting depth to 185 and let's end with 165. Like this, you can see by this temporary graphic how this solution will look like. And when you click apply, the pipe invert is changed. Okay, let's now select the next part of the profile. Let's say, for example, from node 5 to 18. And now let's switch to a different option by slope, where now you can define starting depth or elevation and a slope. So for example, let's increase the starting depth. I will go with 235. So we will have a bigger drop manhole here. And now you can define a constant slope by numerically defining slope or by selecting it graphically from the drawing. For example, let's go like this. I will round it to 32. Okay, and let's click apply. So this is how you can precisely define your pipe invert elevations for all of your profiles. Okay, let's now switch to the following topic, which is definition of the catchment areas. So I will again switch to a different layer state where I have these AutoCAD polylines, closed polylines, forming these catchment areas that you can see here. And now we will use these CAD polylines, we will convert them to Urbano catchment areas. So to do that, let's go to Canalis panel and let's open the function for catchment area definition. So in Urbano, you can define catchment areas so that one catchment area is defined for one section, or that one catchment area is defined for more sections, for example, for a branch, for an array, or for an arbitrary selection from node to node. In this example, we will set one catchment area per one section. So let's select this first section of the network. And now there are many different ways how you can define catchment areas. You can select an object, basically a closed polyline. You can draw the catchment area interactively, or you can select a point inside of a closed polygon. First, I will use this option to select a closed polyline. Let's select this polyline here. And you see the software recognizes this as a catchment area. So now we can define a runoff coefficient. We can define it numerically, or we can select it from this catalog of soil types. So let's set it up to be asphalt with the runoff coefficient 0.9. Let's click OK. Let's apply it and let's save it. So one catchment area is defined. Let's do one more. Let's go to the second section of this network. And now I would like to use this pick point option. So here again, you can use the layer filtering. So just select the element from plan. The software recognizes which layer this is. And now we can go to pick point. And if a closed polygon is found, this will be a catchment area. So again, I will go with asphalt. So just click save. Let's do one more. And now I will do for this section here. And I will use again, the pick point selection to select the center of this roundabout, but I will switch from asphalt to grass. Let's click apply. Now you see we have a soil type grass with the runoff coefficient of 0.30. Let's save this catchment area as well. So now we could continue defining these catchment areas for each section, but I would like to switch to a different drawing, which is basically this same project, but I have this stuff already done. So if we take a look at this profile, you can see that I precisely defined my pipe invert elevations for every profile. And you can see that here in the last node, I deleted a manhole because here we will later have a free outfall. Also, you can see that I defined all these catchment areas, which can be seen from these catchment area labels. If we want to see the data about the catchment areas, we can also open the data table. We can switch to catchment area preview, and here we can check all the data for the catchment areas. Okay, so now that we have catchment areas defined, let's also calculate flows. So let's go to flow calculation function. And here you can see that in Urbano Canalis, we offer many methods for flow calculation for both storm and sanitary flows. And because we support many different countries, many different standards, you see there is a lot of these different methods which you can use. But if you don't want to see all these methods, in version 11 we added a new function which is called selection of calculation methods. Because, for example, if you don't want to see, if you don't use, for example, sanitary flow calculation methods, you can easily turn them off like this. And when you click OK, now you will see a lot less methods available here in the list. For this project, we will use the rain flow simple calculation, which is basically rational method, CIA method, with the constant rainfall intensity. So I created two flow configurations here, one for 2 years return period with this constant rainfall intensity, and 5 years return period with a little bit bigger rainfall intensity. So now let's calculate this. Let's just click right, and with the CIA formula, the rainflow is calculated for each section. Let's repeat this for 5 years return period, and again we see that the flows for each sections are calculated. Let's now calculate transit and total flows. To do that, we can create, as we call them, scenarios. And here I created two scenarios. So again, one for 2 years return period and one for 5 years return period. Basically, in these scenarios, you can group previously defined flow configurations. But for this example, we will keep it simple. So just one flow for 2 years and just one flow for 5 years return period. So now when we click write, the software calculates the transit flows for each section and total flows for each section. Let's go now for 5 years return period and repeat this calculation. Now, if you want, you can go to scenario preview and basically perform parallel hydraulic calculation or parallel pipe sizing for multiple different scenarios. Doesn't have to be 2. You can have any amount of scenarios. But before we do that, I will go to hydraulic calculation options, and here we can set up some options. For example, for the calculation type, it can be calculation according to existing diameters, or we can go with pipe sizing. If we go with pipe sizing, we have to define a pipe group from the pipe catalog, and also we can set up some calculation parameters, for example, maximum fulfillment of the pipes and minimum pipe diameter. So let's click OK, and let's turn on these scenarios. And now you can see in different colors, we can compare and calculate these values for 2 different flows. So we see in different colors 2 different flows, which will result in 2 different sets of diameters. So in this first part of the network, you see there is no differences between these 2 scenarios, but here in the last part of the network, you see that because of the higher flows, we also have the bigger pipe diameters. Also, we see other results. We see the water levels in the pipes, fulfillment percentages in the pipes, and also velocities. But this is just a scenario preview. So if you want to actually calculate and save some values for these scenarios, we have to go to hydraulic calculation, select the scenario according to which we would like to size these pipes. So let's select 5 years return period. All the options are the same as before. Let's click calculate and let's click save. And now you see that the inner diameters didn't change from what we defined in the previous drawing, except for this last 4 sections where now the software increased the pipe diameters. So let's close this and let's go to our plan. And we can see that everything in Urbano is completely automatic and dynamic. So you see how the plan labels and the plan styles automatically updated, showing us now these bigger pipe diameters. Also, if we go to our profiles, we can see that the profile table also automatically updated, and also the pipes automatically updated, showing us now the water levels in the pipes. We can see that we don't have the water levels in the manholes, and we can see that the water levels in the pipes are linear, and that's because this calculation that I just did uses steady state calculation according to Darcy-Weisbach and Colebrook-White equations. Okay, let's now do the same calculation, but now using the EPA SVMM calculation engine. So from version 11, Urbano Canalis version 11, we integrated EPA SVMM 5.1 calculation into Canalis. So before we go to calculation, let's go to hydraulic equipment. So now I will show you what equipment is available. So let's select some sections. For example, let's go to the last section of this system. So we can set up for the section to be a plain section, pump, orifice, weir, or outlet. And also for the nodes, let's select this last node. We can set it up to be a plain node or junction, outfall, divider, and storage unit, with all the parameters available in SVMM. We will set this last node to be outfall, type will be free, and we will leave all the other options as default. Let's click apply. So now that we defined the outfall, let's run hydraulic calculation according to EPA SVMM. So let's go to this dialog, and before we run the calculation, let's go and check the options. So now for the routing model, you can see that we can run steady flow calculation, kinematic wave, and dynamic wave. We will go with dynamic wave, and for this first calculation, I will turn off to SVMM to calculate rainfall and runoff, because I would like to use the flows that we already calculated with Canalis. So let's click OK, and here under direct inflow scenario, I will just select these flows calculated with Canalis, this 5 years return period, and let's click calculate. Now you will see the flows didn't change because we just said to SVMM, okay, calculate with the flows that we already have, but we see the depths and the velocities are a little bit different, but this is logical because SVMM uses Manning equation, and now we are using dynamic wave equation. Also, we see that we have some data that we didn't have before, so we see the water volumes in the pipes and also pipe capacities. Let's save these results and let's switch to a default preview for the nodes, where now we can see that we have water depths and head elevations for the manholes and also some other data for nodes as well. Let's close this dialog and let's zoom to profiles. And now you can see that we also have the water levels showing for the manholes, and we can see that the water levels in the pipes are not linear anymore. They are not constant in each pipe because now we have a dynamic wave calculation. Okay, so this is calculation according to flows calculated with Urbano Canalis, and let's now do a calculation where we will leave SVMM to calculate everything, including the flows. So to do that, we have to define a rain gauge. So let's go to function for adding a rain gauge. For the rain format, I will set intensity. Time interval, we will set 5 minutes. And for the data source, it will be a time series that I previously created for this project. So I have rainfall intensities for 5 years return period. Let's click OK. Let's now go to subcatchments dialog, where you can define all the SVMM available parameters for each catchment area or subcatchment. So here you can see that you can precisely define all these parameters for each subcatchment, or you can select multiple subcatchments or all of them and define the same values for all the catchment areas in the selection. So I will set the same rain gauge to all the catchment areas. And here you can also see that you can define infiltration data. So infiltration method, you can choose between 5 different methods, including Horton, green amp, and curve number that we will use here. So let's click OK, and let's click OK one more time. Let's now go to hydraulic calculation according to SVMM. And now we will turn off this direct inflow scenario. And let's go to options. Now I will turn on this option to calculate rainfall and runoff. We will do a 2 hours simulation with the reporting step each 5 minutes and the runoff step each 1 minute. Let's click OK. Let's run the calculation and let's save the results. So now we can see that we have 24 sets of results for each 5 minutes of the simulation. And now we can go through time, apply those results. So we are now 10 minutes into the simulation, which is our peak flow. You can check all the results in the data table. You can even label your sections and nodes in plan with these values. And also you can check the results in the profiles. So let's zoom to this profile. And now we can go through time like this and apply the results for that time period. Also, we can go to a default preview for the nodes to check the results for the nodes. And now we can also go to a preview for the catchment areas, where we can see now that EPA SVMM calculated also the precipitation, infiltration, and runoff data. Let's go back to the default preview for the sections. And this is a standard preview where you can see all the data for all the elements in selection for one time period. So you can go through time and apply the times to see the values. But also we can go to preview by object, where you can select an object. It can be a section, it can be a node, it can be a catchment area. For example, let's select this last section of the system. And now for one element, we can check all the data for all the times during the time simulation. Or we can go to preview by variable, where we can define which variable we would like to check. For example, let's go with flows for the sections. And now I can select multiple sections. For example, let's select this one, this one, this one, and the last one. And now you can check these values, compare them, analyze them for multiple elements at once. but the best way to analyze these time-dependent results is always by drawing some graphs. So let's draw these time series graphs. You can select up to three data. So you can choose between data for sections, for nodes, and for catchment areas. So for data number 1, we will select section flow. For data number 2, we will select a node depth, manhole depth. And for the data number 3, we will select precipitation for the catchment areas. And now you can select one or more elements. So let's select this section. Let's select this last node, the outfall. And let's select this last catchment area. Okay, and now we can compare and analyze these values, everything on the same graph. You can also add, like I said, multiple elements and do all kinds of analysis, and also you can draw these graphs to CAD if you want to have them in CAD. Okay, and the last thing I would like to show you here, let's go to rain gauges. Let's now replace this 5 years return period time series with this time series that I created with very high rainfall intensities that will result in flooding. Let's click OK. Let's zoom to this profile. Okay. Let's go to hydraulic calculation according to SVMM and just rerun this hydraulic calculation. Let's save the results. Let's go through time. So 10 minutes into the simulation is our peak flow. So let's click apply. And now you will see that because of the very high rainfall intensities that I defined, we have a lot of very high flows, which will result in some pipes being 100% full. And also if we go to the default preview for the node, we see that for some nodes, we also have overflow or flooding. So these nodes 13 and 14, we see that we have flooding. But if we go through time, we will see that these water levels will start to drop. So at this point, we see that we have no more flooding. And like this, we can go through time and, for example, I think 40 minutes into the simulation, the water will go back to our pipes. Okay, so this is some very exciting new features in Urbano 11 Canalis regarding this EPA SVMM 5.1 integrated calculation. So we are now done with this hydraulic calculation, hydraulic modeling part of the presentation. And let's now switch to something different, which is more of a detailed design features. And now I would like to draw the storm drains. So you can draw storm drains by interactively drawing in plan, or again by converting AutoCAD elements. So here you can see that I have 29 plain AutoCAD lines that represent the positions of these storm drains. So let's open the function for drawing of the storm drains, where you can automatically set the pipes for those drains. You can automatically define the terrain elevations from selected DTM surface, and we will go with the constant invert slope of these pipes of 20 per miles. And also we will define a starting depth in the drain node, invert depth of 1 meter. Also, you can define some prefix, some name prefix for these drains, like this. And again, we can use this standard layer filtering option to select some element in plan, like this. And now we can select the whole drawing, and the software will filter out and select only those elements on selected layer. So now let's click draw, and everything will be converted from plain AutoCAD lines to this Urbano storm drains elements. Okay, so now that we draw these storm drains, let's also draw their profiles. So let's go back to home. Let's select a profile configuration. Now I will use this slightly different configuration in a larger scale, 100 to 100. Let's select all the subsystem elements, so all the storm drains, and let's draw their profiles. Again, you have to just select the insertion point and all the profiles will be drawn. Okay, let's now take a look at them, and you can see how I defined the pipe slope is exactly 20 per miles, and we see that the invert depth in the starting node, in the drain node, is exactly 1 meter, and we defined those values for all the storm drains. Okay, let's now set the manholes. So let's go back to this function for setting of the manholes, and I will now use different manhole for the storm drains, smaller manholes, and I will define a manhole depth below the pipe for the sedimentation tank 1 meter, and I will select all the nodes in the drawing, but I will use node type filter to select only the drain nodes. And let's now click save, and you will see that each drain will now have a manhole like this, and we see that we defined that type of the manhole for all the storm drain nodes. So now that all the manholes are set, let's also draw the manhole schemes. So this is another great function in Urbano, and like everything is stored in these configurations. Like I said, from scale to data to colors, hatches, dimensions. So let's select this manhole scheme configuration. I will select all the manholes in the drawing, so 57 manholes, and let's just click draw. Again, let's define the insertion point, and in a matter of seconds, these 57 manhole schemes are drawn. We can take a look at them, and like I said, all this data, this plan and profile views, dimensions, everything is defined in this configuration. Okay, so this is a little bit a bigger scale because I would like to plot these to A4 papers. And to plot these manhole schemes, in Urbano 11, we added a new function for plotting these kinds of drawings, for example, cross sections and manhole schemes. So let's go to tools, to this new function. First of all, we have to define what we are plotting. So we will plot manhole schemes. And now we can select all manhole schemes or just some of them by using interactive or CAD selection. I will select this first row. And now we can define a paper. We can set up some standard paper parameters like orientation, margins, title block. We can draw one drawing per paper or multiple drawings per paper. We'll go with one drawing per paper. We have to, or we can select the layout template. And when we click plot, all these selected manhole schemes will be plotted to layout. So we can take a look, and we see that each layout is named according to the manhole scheme. So we can take a look, and these manhole schemes are ready to be plotted, for example, to your PDFs. So let's go back to model, and let's now also plot the profiles. So in Urbano 11, we also have a new function for plotting of the profiles that is very easy to understand and to use. So first of all, you have to select the profiles. You can select all of them or just some of them. So I will select these three profiles, the main profiles. And again, you have to select a paper format, and you can define some standard paper parameters like orientation, margins. You can select the actual title block or just leave the empty space so you can insert your own title block later directly in the layouts. And first of all, we have to draw frames. So you can set up some parameters, and when we click draw frames, you can see that these helping frames are drawn. Let's now go to function drawing frames to layout, where again you can set up some parameters. You can define the layout template, and I will use this really nice option to draw folding marks, so we can easily fold this paper roll that I'm using to standard A4 paper format. So let's now click plot, and everything will be plotted to layout. So this is the profile A1, as we see splitted to 3 views. We see these folding marks that I said, so we can easily fold this paper to A4 format, and we see this empty space that we left for insertion of the title block. Let's also take a look at the profile A1.1 and also A1.2. Okay, so at this point, I would like to go back to model, and now I would like to switch to a final example today, where I would like to show you intersections between multiple pipe infrastructure networks. When I say intersections, I mean crossings and clashes. So here you can see that we don't have just one network anymore. We have more networks here. So we have our storm network, but also we have sanitary network, water network, culverts, and also open channels. It is important to say that from Urbano 11, we added the possibility to design and run hydraulic calculation according to EPA SVMM for the open channels. So here you can see one mixed system, basically a combination of these open channels and these culverts going through the body of this newly designed road. And also what is important to say that whenever you draw something new, or for example, if you import it from some external file sources, all the crossings and all the clashes in Urbano are completely automatic. So if we take a look at our profiles, we see that now we have the relative positions of all the other intersected pipe networks. For example, this is a profile of our sanitary network, and we can see these relative positions of the sanitary pipes and also the position of this culvert. Also, if we take a look at the water profile, we see this storm pipe here, and also we see this intersected open channel. So this is standard intersection analysis between multiple Urbano pipe networks. But also in Urbano, we can analyze intersection analysis between Urbano pipe networks and also groups of CAD elements. These plain CAD elements can be basically lines, 2D or 3D polylines. Here we have some 2D polylines, which are basically Croatian Telecom cables. And now I will run a intersection analysis between Urbano elements and these plain CAD elements. To do that, we have to create so-called groups. So let's go to intersection panel and let's go to function CAD element groups. We have to create a group. So let's give it a name. I will call it HT, like Croatian Telecom. And then I will select a layer from the plan like this. And now I can freely select all the elements on that layer like this. And now for that group, we can define the data. We can define the same data for the entire group, or we can individually define it for each polyline. So let's define a pipe group to be PVC pipes. Pipe will be, for example, 110 diameter, and we have to define the position below the ground. So let's say that the top of the pipe is on the constant depth below terrain of 0.60 meters. So now this group is defined and it will be treated as any other Urbano pipe network. So let's click OK. And to show these intersections in profiles, all we have to do is go to Profile Manager and select all the profiles of all systems and just redraw them or refresh them. And in a matter of seconds, all of them will be refreshed. And now we can see also the relative position of these Croatian Telecom cables in our profiles. So these are the intersected pipes that we see here. Okay, so if we need to see this data about intersections in plan as well, to intersection settings, we can turn on automatic labeling and define the label configuration that we would like to use. Let's click OK, and now we see that we have these really nice labels also appearing in plan, showing us, for example, this is a 3D distance, the shortest distance between two intersected elements. We see the terrain heights in the terrain elevations in the intersected point, and also we see the depths of both intersected pipes. If this happens, if we have the overlappings of the labels, we can easily move those labels with the new function that we have in Urbano 11. So just go to Move Labels and easily move these labels. If you need more information about these crossings and potential clashes, we can go to this intersection preview where you can see all the data about these intersections. So when you pick in the data table, you can automatically zoom to those crossings in plan or in profile, and you can see all the data about these intersections. For example, which systems these are, which pipes these are, what are their nominal diameters, and also if we scroll to the last column, we see this really important data, which pipes are below or above selected pipes. Also, we can sort this data table by distances. So we see that in this example, we don't have any physical clashes. We just have the crossings of the pipes in plan. But if I go to the second tab here, so these are pipes with pipes, but if I go to second tab, which is pipes with manholes, we see that we have two clashes here. So let's select it. And we can see that these clashes are between these Croatian Telecom cables and this manhole of this storm drain. So we can easily resolve this. So let's go to function for moving of the node. And I will just easily move this storm drain node here. And now you can see that the data table automatically refreshed and we have no more clashes between pipes and manholes. Now I would like to show you what's new regarding this intersection analysis in Urbano 11, and that is the possibility to analyze this intersection analysis between Urbano pipe networks, including these groups of CAD elements, with AutoCAD 3D solid or 3D mesh elements. So here you can see that I have some 3D solid elements for these retaining walls and foundations. And also we have some traffic signs here with these traffic sign foundations also as 3D solid objects. So just like for the lines and polylines, we have to create a group. So let's go to the second function here, which is very similar function. So create a group. Let's give it a name, let's say walls. Again, we can use the layer filtering. Select everything on that layer from the drawing, and one group is created. Let's now create another group, and I will call it TS, like traffic signs, and I will select this traffic sign foundations layer because I'm interested in only what's happening below the ground, but if you want to analyze some other intersections, you can select other elements as well. So let's select all the traffic sign foundations, and two groups are created. Let's click OK, and let's now go to intersection preview. I will turn on drawing of 3D, and let's now go to this special new tab, so intersection of everything else with 3D solid and 3D mesh elements. And here you can see that basically the software works the same. It calculates the overlappings, the crossings in plan, but this is not so important here. So let's turn on this filter to show only collisions, to show only clashes, and you can define collision tolerance. Let's say basically clearance. So let's define 20 centimeters. But we see that we are good. Everything is on a bigger distance than 20 centimeters. So now when I pick inside of the table, I can see these clashes. So let's see more of them like this. So these are basically clashes between Urbano water network, water pipes, and these retaining walls and their foundations. But this is done according to this real project, so this is not an issue here because we can just place those pipes inside of a protection pipes, which can also be done in Urbano. But here we have two problems. This is a clash between Urbano manholes and these foundations of these traffic signs. So let's now close this dialog. Let's go back to plan view and let's resolve this. Of course, we could easily move this Urbano manhole, but it's easier for me and I believe for the traffic designer as well to just move this solid like this. So whatever you move, the point is that everything is completely dynamic and automatic like this. And now let's go back to 3D. Let's go to intersection preview. And now you can see that the table automatically updated. So now only these three clashes remained that we said they are okay. Okay, so now that we have clash-free model, let's also create a 3D beam model. So to do that, first of all, let's show all these pipe infrastructure systems in 3D. To do that, I will use this multi-system input and I will apply 3D style to all these networks. So in Urbano, 2D or 3D is just a matter of style. So if you want to show your network in 2D using AutoCAD lines and blocks, you can. If you want to show your network in 3D using AutoCAD 3D solid objects, you can do that as well. So these are now AutoCAD 3D solid objects, but they are live model elements. So even if they are in 3D, if I change something, the 3D view will automatically update. And here we can see our pipes, manholes, drains, we see the other pipe infrastructure systems, we see these open channels, culverts, everything is here. Okay, so let's now export this to IFC. To do that, let's go to Urbano BIM panel. And first of all, I would like to show you this data configurations. This is a function that you can, where you can define the data groups to be exported with your 3D BIM model. So here I created some groups. You can create them once and then use them for all of your exports. For example, I created geometry data group, some excavation data group, SVMM data group, and so on. So let's now go to IFC export. And here you can define all the systems that you would like to export, all the DTM surfaces, and also for each network you can define which data groups you would like to export with the 3D elements. So for the storm network, we will have geometry data group and SVMM data group, and for all other networks we will have just geometry data group. So let's now export this to IFC, and in a matter of seconds this will be exported. And now we can open this IFC with any BIM viewer. I like to use Autodesk Navisworks, and here it is. This is the entire model that we exported from Urbano with the addition of these retaining walls. That is basically a DWG file. And here we can see everything. We see the existing ground. We see the finished ground that now I will hide because I would like to see my pipes under the road. And for example, let's select this storm pipe. And in the properties dialog, we can see these data groups exported from Urbano. So this is geometry data group. Also, we see the SVMM data group. And also, if we select a manhole, we see this SVMM data. So even in our BIM model, we can see this hydraulic calculation, hydraulic modeling data calculated with Urbano, Canalis, and EPA SVMM. And for the final thing today, I will also show you this road. So let's just select this roundabout. Let's unhide it. And this is how our final aggregated model looks like. So we see this roundabout and these roads are created with Civil 3D. Also the terrain surfaces are created with Civil 3D, and all the pipe infrastructure networks, including this system of open channels, are created with Urbano. So that's it for me for today. I hope you liked it. I hope you would like to test it and try it on your own projects. And now, before we go to Q&A, I will give a final word back to Michael. Thank you all.